Fraction division. We will first derive an approach to dividing fractions. Then we will develop a simpler algorithm for fraction division based on that approach. In practice, the algorithm is what you will use when dividing fractions, but it's important to know why it works. The first fraction here is divided by the second fraction. We can always express that division as a fraction, as shown here, 4/5 over 3/7. This is called a complex fraction, since it's made up of fractions. To simplify this, we can multiply the denominator of the complex fraction by a fraction that will make the denominator have a value of 1. This is done by multiplying the denominator by its reciprocal. The reciprocal of a fraction swaps the fraction's numerator and denominator, flips it over. The first fraction shown here is the denominator of the complex fraction. The second bolded fraction is its reciprocal, right? We just flip it upside down. Therefore, the product of any fraction and its reciprocal is 1. So 3 times 7 is 21, 7 times 3 is 21, 21 over 21 is 1. However, if we only multiplied the denominator of the complex fraction by its reciprocal, that would change the value of the overall fraction, the complex fraction. We need to make a representation of 1 to multiply by the entire complex fraction. So we're going to flip the denominator, but we need to create a new complex fraction that equals 1. Because whatever you do to the bottom, you're going to have to do to the top. So 7/3 divided by 7/3 is 1, which is why we can multiply this whole thing by 7 over 3 over 7 over 3. After multiplying all of this out, the fraction in the denominator has become 21 over 21, which equals 1. So look, 4 times 7 is 28, 5 times 3 is 15, 3 times 7 is 21, 7 times 3 is 21. But look, this is about to become 1, which means it will go away. Converting the denominator of the complex fraction to 1 yields the final answer. So 21 over 21 is 1. And look, when you divide by 1, remember a divided by 1 equals a. So when you divide by 1, you can just get rid of it. The answer is 28 over 15. Studying our steps will yield a simple, fast algorithm for dividing fractions. The net effect of all of our work was that we end up just multiplying the first fraction by the reciprocal of the denominator fraction. The other parts grayed out, justify why this works, but they don't change the result. So if we just take the top fraction and multiply it by the reciprocal of the bottom fraction, you get the answer. Dividing by a fraction is always the same as multiplying by its reciprocal. Every fraction division problem becomes a fraction multiplication problem. So 4/5 divided by 3/7 is the same thing as 4/5 times 7 over 3. Convert each of these into a multiplication problem and then solve it. 3/5 divided by 8 over 11 is the same thing as 3/5 times 11 over 8. 3 times 11 is 33, 5 times 8 is 40. 1 divided by 9 over 13 is the same thing as 1 times 13 over 9. And remember, 1 times a is just equal to a. The answer is 13 over 9. Negative 3 2/3 divided by 8 over 11. Well, here we need to first convert this into an improper fraction. So first we multiply 3 times 3, then we add 2. So 3 times 3 is 9, plus 2 is 11 over 3, and it is negative. Then we're going to multiply by the reciprocal, 11 over 8. And so we get 11 times 11, which is 121, over 24, which is 3 times 8, and it is negative. 3/5 divided by 2. Well, what's cool is that 2 is the same thing as 2 over 1. So look, now we have a fraction problem. Therefore, 3/5 times, flip it, 1/2. 3 times 1 is 3, 5 times 2 is 10. The answer is 3/10. And there you have it.